To not bore you with the basic stuff, I will go on with some advanced stuff, and for this I brought a case study that is incorporating several patterns you need in a large enterprise applications. Patterns like subforms, you see it here. I have a flight, I have prices for the flight, and I have an aircraft. Or things like a repeating group. You can add several prices, and even this repeating group is validated. You cannot have two prices for the same flight class, for premium or economy or something like this. Another thing that is interesting here is that we can even validate several of those fields. From and to have been different. And also we have here a custom control, our delay picker that allows us to increase the delay by 15 minutes on a regular basis. And in this talk I want to show you how to implement those advanced patterns with the new signal forms. Before we get started, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I'm helping a lot of companies with trainings, with consulting, and also with reviews. Besides this, I'm quite connected to the Angular community. I live in Austria. I do a lot of stuff in Germany, and I'm always happy to work together with people around the globe, for instance here in France or also in other countries. Before we jump into the advanced topics, let me quickly give a primer into signal forms, just a little tiny amount of slides to get everyone into the boat. So when it comes to signal forms, you start with a signal, with a data structure representing your form. And this data structure can be deeply nested. As you see here, I have here a flight with an aircraft. It could even have prices and so on and so forth. Once you have this data structure inside of one signal, you put this signal into this form helper, and what you get out is a so-called field tree. A field tree is a deeply nested signal. A signal with signals with signals. That means each and every node in there, the ID, from, to, the aircraft with its type and its registration number, becomes a signal of its own. You don't have to handcraft this. And each and every signal consists of form state, like this is the value, this is whether it has been touched or it is not dirty, this is whether it has been validated correctly, and so on. You can see it here, kind of. You see here, I have my from fields, my airport of departure, and it has some nested signals like valid, errors, and value. And I can go even further down the rabbit hole to the aircraft, its registration number, and also there I can find out about whether it's valid, about its value, and whether there are specific errors. Last but not least, you bind everything to your field controls, to your inputs, to your drop-down fields, and meanwhile, you should also bind the entire data structure to your form using form root. Form root is used for the entire data structure. Form fields is used for all the fields in there. There is one further thing I want to tell you before I'm closing this first tiny part with the primer. It's about the schema. If you set up your signal form, you can put in a schema. There is the second optional parameter, and the schema is setting up rules for your form. Most of the times, those rules are about validation rules. Sometimes they are also describing some other behavior, like that sometimes this field should be disabled or hidden, that sometimes this field should be validated in a different way, or that sometimes this field should be debounced. But most of the times it's about validation behavior, like here I'm saying, well, from the airport of departure is required and there is a min length of 3. And then, Your inputs are validated against the schema, and you will find out by looking into your valid property you have seen before or into your errors array. Okay, so this was the primer, just to get everyone into the boat. Now let's concentrate on the more exciting and advanced parts of this new fresh API. And for this, let's get started with splitting an entire form into subforms like here, where I have my flight and prices and the aircraft. And when it comes to this entire topic is a lot like the 1980s. You know the 1980s. You need to experience them. Otherwise, you don't know what they were about. That's why I'm directly jumping into a demonstration now. Okay, so in this demonstration, I'm getting started with my advanced flight edit component, the component you have seen before on the slides. And if you scroll in there, you see this form helper that gets an entire flight and a flight schema. And this schema defines how to validate our flight, like that this or that is required, that we have a minimum length here or there. It's getting a bit more interesting when we remember the name, flight form, the name of our entire, you see it here, field tree of flight, this deeply nested data structure, and when we go into the HTML with it. Because the HTML here is really tiny. It's really tiny and concise. It's just a form with form root flight form, and then I'm delegating to 3 subforms. One for the flight, one for the prices, one for the aircraft. And now let's have a look at the data types in there. This is always the first thing I'm doing when looking into a new API, finding out which types I'm getting back. Obviously, as we know, flight form itself is a field tree of flight. A field tree of flight. However, app prices gets flight form prices. So what is prices here? Oh, it seems like it's a field tree of price array. How convenient. And what's the aircraft? Well, the aircraft we are passing down to the subcomponent app aircraft is a field tree of aircraft. So it seems like that our entire data structure is recursive, that a field tree consists of field trees and they in turn can consist of field trees. That means everything we need to do in there, in those components, is tinkering an input that takes a field tree of aircraft, a field tree of price array, and so on. And this is exactly what I'm doing here. I have my new input. It's a signal-based input set up with this new input helper function. It's a required input, and it's of type field tree of price array. So give me your field tree representing the price array, and the result of this here is an input signal. This is what happens when you are defining a signal-based input. You get an input signal, which is kind of a signal. And now we have a first little tiny challenge, but nothing we can deal with together. Namely, now what you see here is a signal inside a signal. Because the input signal is, as the name tells us, a signal, but also the field tree itself is, as discussed before, a deeply nested signal. And that's why we need some parentheses, you know. Here I'm unwrapping the outer signal, parentheses, and there I'm unwrapping the inner signal. I've done my best to just hide this aspect by splitting all of this in 2 lines, because we don't want to have full parentheses, full parentheses, full parentheses in 1 line of code. But besides this, once we have dealt with this, it's just going on with signals. We can update our array by adding a new price here, a new price that is a copy of some template, and all the other prices are perceived. So when going into the HTML here, one more time we need to unwrap our prices. For this I'm using this let directive. And once I've unwrapped the prices, I can just iterate them and implement 1 table row per price. It's really as easy as that. It's really as easy as looping through a collection, something we are doing on a regular basis. And this really shows a huge difference to reactive forms, where dealing with form arrays always was a bit special. It was always a bit of a pain. Here it's really natural. Just iterate your array and render out a table row or something else per each record. In there, one more time, we are using inputs with form field, and there we are binding to flight class or the amount. And the result of this is having a repeating group. Let's go in there, edit, show details. It's this repeating group here with prices where I can say, hey, I have those 3 prices. Once for the gold class, once for the silver class, once for the wooden class where you're sitting outside at the wings, hopefully with some belt or something like this. Might be a bit cold there. But there is another thing in there. I'm validating everything in there. So if I'm not adding a class name, I'm getting this error message. And if I'm defining gold twice, I'm getting another error message that I'm not allowed to have 2 prices for the same class. So let's find out how to set up those validation rules. For this, I'm switching back to my advanced flight edit form. And you remember there is the form helper that gets our flight signal and the schema. And if we look to the schema, we not only have here rules for the atomic fields like from, to, date, no, we also have schemas for the nested objects. And those schemas are applied using apply or apply each. With apply, we can define that a subcomponent, a sub-object, gets a schema of its own. Like the aircraft gets here this aircraft schema, which tells us that the registration number and the type is required. When it comes to the price, it's a bit different, because here I don't want to apply rules to the entire price array. No, I want to apply rules to each and every entry in this array, and that's why we are going with apply each. Apply something to each and every price in this prices array. Apply this price scheme that tells us that each and every price has a required flight class and required amount, and the amount should be at least 0. At least 0, because I found out, and this is now a good hint for everyone who is into business economics, negative prices are not good for your business. This is something I found out by myself, so please respect it. Okay, cool. So this was quite straightforward. Applying additional schemas to sub-objects or to repeating sub-objects in arrays. But we can go even further. Here I have my own validation rule, validate duplicate prices, which just gets a pointer to my prices array. So how does this work? Well, it turns out that it is quite easy to implement your own validation rules with signal forms by just having a function, calling the validate function that ships with signal forms. This validate function takes something you want to validate, some path in your entire data structure, like the prices, like the aircraft, like your airport of departure or destination, and then there is your lambda expression. And when it comes to this lambda expression, there is one rule I learned in Germany, in the southeast of Germany, no, in the southwest of Germany, namely, not complaining is praise enough. So if you don't say anything, then the validation was fine. However, if you start complaining by returning an object with an error description, then you really have an issue. And this is what's going on here. When I find out, hey, I have seen this flight class more than once, then I'm just returning this object describing your error. Usually, each and every object has a kind property that is denoting your error you have, and then you can add all possible properties. This is now very specific to your situation. You can add everything that gives the user a bit more context about the error itself. Something you might add to a translated error message, like this message itself or the flight class that has been duplicated. If we look to the entire implementation here, I'm starting with a set. The set contains all the classes I have seen so far. I'm iterating through all the prices. If I have seen the flight class of the current price, I'm returning an error. And after that, I am making sure to remember this flight class to find out about duplicates a bit later. Yeah. Custom validation rule just by calling validate. And in there, I'm going over my entire flights in the array. Yeah, nice. So this really allows us to nicely break down a very, very huge form. And when it comes to business applications, you often have huge forms to a lot of little, tiny, simple, maintainable components. The second thing I want to tell you about is also something that was not possible before with traditional forms in Angular. It's conditional validation. For instance, here I have a delayed flag, and only when this delayed flag is activated, my delay becomes a required field, and it needs to be 15 minutes at minimum. Because I'm very sorry, where I come from, it is not a delay if it is less than 15 minutes. Some people argue about this, but where I was raised, this is the current rule. You are totally in time when you are less than 50 minutes delayed. And see this as a proxy for more complex scenarios where a value here is affecting how you are validating something over there. It might be a difference whether a contact is an email address or a telephone number or a postal address. You might have different rules for those kinds of contacts, and this is just another example for something like this. So how can we implement this? Well, let's have a look into the demonstration. In there, we see besides apply and apply each, we have something like apply when and apply when value. So what I'm saying here is apply to my path, to my entire tree with the flight and the aircraft and the prices, another scheme when the flight is delayed. And this further schema just tells us, well, the delay is required and it needs to be 15 minutes at minimum. Just when flight delayed is active, apply this here. Okay, so let's also talk about metadata. This is really nice. This is also a feature that was not possible before. Usually, we yell at the user when they are doing something wrong, when they are entering too much or too little or something that does not fit our schema. However, instead of telling the user afterwards that they did something wrong, it might be better to tell them upfront. And this is what metadata is about. Telling the user upfront about what they are supposed to enter in this field. For instance, with this asterisk here, that tells us, hey, this is a required field, or the characters for the min and max lengths, or the information that you are supposed to enter a city name in there. All of this can be set up with metadata. So, how to do this? Well, let's have a look into my source code. Let's have a look into my flight form. And there, for each and every field like from and to, you see I'm calling a helper component that is called field metadata pane. So if we go in there, you see I'm getting a field as a field tree. I don't care about the data type of this field tree. Can be everything. I don't care, but I want to have the field tree via an input. And then, one more time, I need to unwrap it twice. Once because the input itself is a signal, and then because the field tree is a signal. So I need full parentheses, full parentheses. I also call this the swollen A operator, because it looks a lot like my swollen eyes in the morning after coding the entire night. But after that, I can go on in a quite nice way. I have my field state here, and now I can ask the field state, hey, give me the metadata for required, for min length, for max length. It turns out that most of the built-in validators have some metadata keys. Metadata keys like you see it here, required min length. So you just have to ask for the value associated with this key. And even better, the default validators assign this metadata because the default validators know about the metadata. They need to know about it because they need to validate against it. And so they tell us upfront what we are supposed to enter here so that we don't get a validation error. So just ask for required, ask for min length, ask for max length. Funnily, you can also define your own metadata key. This is what I did here with city. And defining your own metadata key is as simple as doing something like this. Defining a constant with a nice name that matches your own validators, and call create metadata key, define a data type. It goes a bit further. For advanced scenarios, you can even define a reducer for your metadata, because it could be the case that the first validator says this is a city, and another validator says this is not a city. Then the big question is who is right. And for this you can define a reducer that says let's apply a logical and or a logical or. If only one guy is telling us it's a city, then it's a city, or everyone needs to tell us it's a city to be a city, something like this. But this is more or less for more advanced scenarios where you have conflicting information for your metadata. Here, I don't have this. Here, I'm just assuming that just one validator is telling us whether it's a city or not. Also, this metadata is here read, and then I can use this metadata to display this information just with an if. If we look in there, it's just about ifs. If we have the required metadata, show this, show some information about the length, min length, max length. If it is a city, show that. So now the big question is, how can we set this metadata? Well, let's go back to the schema. The easy approach would be to just call metadata in there, metadata, with our metadata key, city, with the path, then the metadata key, and then an expression that is telling us whether it's a city or not. Let's import the city from our file. Let's make sure we are importing everything here in the right order. Let's remove this unnecessary import, and here we go. You just defined your metadata directly. That's possible, but usually you don't do this. Because usually when you need metadata, you have a custom validator like validate city. And if you go in there, you can call it directly before doing your own validation logic, calling metadata with the path in question, with city, with this or that piece of information. And so the validator does both, checking your values and defining the information you need. Yeah, nice feature, telling the user upfront. There is a little tiny pitfall, by the way, when it comes to null or undefined. To cut a long story short, you should avoid undefined and null. You are allowed to go with null. Sometimes it's necessary. For instance, if you have a number field and you don't have a default value for the number field, then you need to go with null. But as a matter of fact, undefined is not allowed, because undefined means that the field does not exist. However, we have seen before that at runtime, a field tree is constructed, a deeply nested signal. And to construct this deeply nested signal, we need to know about the fields in there. We need to know that we have from and to and date and ID and so on. And that's why undefined is really counterproductive. So don't use undefined. You will get this nice error when going with undefined. Angular is not shy. Angular will tell you that this is not allowed. So the big question is how to get rid of this error here, and the answer is, and this really fits well to the idea of architecture and to representing objects at different layers in different shapes, the solution here is to distinguishing between your domain model and your form model. Your domain model might use optional fields, might use undefined. Your backend could tell you there is no delay by just skipping the delay or setting the delay to undefined. However, in your form, there is always an undefined field. There's always a delay field. Sometimes it might be hidden, sometimes it might be disabled, but it's always there. So there's always a number, and that means somehow you need to convert between those two representation styles. In the case of delay, it's easy, isn't it? Because if we don't have a delay, we can convert it to 0, which is semantically the same as not having a delay. So please keep this in mind. Sometimes you need to convert between those two shapes, between your domain representation and your form representation. Last but not least, custom controls. So what I have in there in my application is this custom control, my delay stepper, that allows us to step through delays in steps of 15 minutes. So let's have a look into a demonstration for this. For this, I'm moving over to my flight form, and in there, I'm calling my delay stepper. And this delay stepper is using form field as all the other baked-in controls, like my input is using it, form field. We have the same here. So it looks like an ordinary control, but indeed, as you see here by looking at the name, it's a custom control. So the big question is how to implement such a custom control that is respecting something like form fields and all the validators. In former days, for this we needed a control value accessor. Who is using the control value accessor? Yeah, most of you. So my idea is, if you make a top 10 list with your most favorite Angular features, the control value accessor does not make it into this list. And perhaps it does not make it into your top 100. I'm not sure, but perhaps it does not make it into the top 100. It always was a weird API. And funnily, now it's really simple. Now, instead of going with your control value accessor, all you need is a value property in your custom control. A value property that is of type, you see it here, model signal. A model signal is a writeable input signal. You can change it to send back the value to the caller. Underneath the covers, it's tinkering something like a changed event. You know, as we have value here, this model signal makes sure you also have value change to apply with the rules for two-way data binding. So this is everything you need. However, forcing people to align with a naming pattern and specific types is not that nice, isn't it? That's why the Angular team gives us here an interface that forces us into implementing the value. If we don't have the value, we are getting squiggles telling us that this interface has not correctly been implemented. And if we look in there, we see we are inheriting from form UI control, and there we have a lot of optional fields. We can implement those optional fields to get more information about the current state of the validation. Are there errors? Are we disabled? What are the reasons for disabling our field? Is it read-only? Is it hidden? Is it unvalid? Pending, touch dirty, required, min length, max, and so on and so forth. So if you need this information, just implement those optional properties. They're really optional. You can completely live without them, but if you need this information, implement those properties, and so you can use those properties at runtime. In my case, when my field is disabled, I'm just displaying no delay here instead of displaying an empty field. Okay, last but not least, one more thing. Perhaps you're saying now, yeah, this is really cool, but I cannot afford updating everything at once to signal forms. Even though we have AI and chartered-based coding, we cannot afford to update everything at once. And for this, you can go with a stepwise migration. So what you see here is really funny. Here I have a reactive form inside a signal form, inside a reactive form. This is what I'm calling matryoshka puppet style. You know, I'm putting everything together like matryoshka puppets. And let me show you how straightforward this is by moving over to my check-in info TS or my check-in page TS. So in there, what you see is that I'm lost. Here we go. What you see is that here we have a signal form control. And this is a nice hybrid. It's an adapter. It looks like a reactive form group to the outside, but to the inside it's just a signal form. You can validate it here with all your signal form-based validators, with schema, with required, and so on. But to the outside, it's a reactive form control. And because it's a reactive form control to the outside, you can put it into a form group. You see it here, my form group with first name, last name, and here I have the phone number with this hybrid from there, signal form control. And then I have this form group and I can put it into a signal, which is a bit weird. I have a signal with ordinary properties and a form group. And then one more time, I can put this signal into compat form, which works like the ordinary form helper, but it also respects those groups in there, those form groups in there. And now I have the best of both worlds. Now I have my nested scenario, everything plays together, errors and all the form state is propagated upwards so that the entire form is touched when something in there is touched. And as a result, you can nicely data bind this to your forms as you have seen before with form root and form field. So it's really as straightforward as this. And by the way, if you like this, you can use this in production beginning with next week, because all of this becomes stable with Angular 22. How cool is that? If you like all of this and if you want to learn more about this, you can look up my ebook here, and you find it at angular-book.com. And for you today, I have this voucher code, so use it Paris-2027. Some people are taking pictures, so go there and get your book. Awesome. So let me conclude. What did we see today? Well, first of all, we have seen that signal forms are really a cool brand new API, perhaps the best API in the entire framework. It nicely allows us to split large forms into tinier forms, to break them down to subcomponents. It's really straightforward to have conditional validation, When this is true, validate this in a different way. We have metadata. No reason to yell at the user afterwards. Tell them upfront what they are supposed to enter. We have this idea of null and undefined. We should convert it to something in our form model. You can easily go with custom controls, and you can go with an interop scenario, your Angular-based Matryoshka puppets. And that's it. So thanks for having me. It's always a pleasure to be here in the City of Love. I have already uploaded my slides and my examples to my blog, and follow me on social media to stay in contact. Thank you.